is height above the ground, and this is energy. Okay, and we know that the maximum value for energy that we found was mgh, and the maximum height was h, so that is over here. I would like to ask you a question. What do you think about this point? At this point, what can you say? What is the height? What is the energy? Or basically,
Maximum height, maximum energy.
maximum height, maximum energy. Good. Because for this point, the corresponding height is this, and the corresponding energy is this. Okay, so that's quite good. Now, that was a point. I'm going to draw a line now. So this line will be starting from the origin and coming to this point. Okay, so I want you to now study this line and tell me what is happening, or what is this line telling you, okay, or what information the line is conveying. So what happens over here is, as you move from left to right, the height is increasing, and so is the energy, and that is what you see along this line. Okay, so as you go from left to right, that means as the height increases, the energy is also increasing. Okay, very good. So now you know what does the line representing. Okay, so for a free falling body, what do you think? This line is showing you how the potential energy is changing, or the kinetic energy is changing. The answer is, it is showing you potential energy. Okay, the reason being, Naisha, you can see that the height increases, the energy also increases. And you know what is potential energy, that is mgh. So as you go to a higher height, what increases? Potential energy, because h increases. And that line I'm going from here to here. Okay, so the question is, what is this representing?
Kinetic energy.
Okay, so as you go from a lower height to a greater height, the energy is decreasing, and that is what this line indicates. So as you go from left to right, okay, energy value decreases. So this is showing us kinetic energy. Okay, now what more is this point of intersection? So at this point, the height is half, and the energy is also half. So at this point, the kinetic energy and the potential energy will be equal, and they will be half of the total energy. So what you see is a pendulum that is oscillating, and it is oscillating like from C to B. Now A is called as the mean position of the pendulum, and C and B are called as the extreme position. At what point is the pendulum bob having a maximum velocity? Is it at A, or is it at C or B? Where is the velocity maximum? Okay, so A is correct. The thing is that when you are oscillating, like say for example, you are on a swing, and then the swing goes like this. So you imagine sitting on the swing. Now when you're going ahead, you stop here, you can't go any further. That means your velocity becomes 0. And on the other side, when you're going on this side, again, you can't go any further than that. That means your velocity is 0. Also, if you recollect from your previous experience on a swing, you are at your fastest over here. And because of that, you could go ahead. So the velocity is maximum at A, which is the mean position. And something which I said, that at the extreme position, you have to stop, or you do stop. And that is when the change in your motion takes place, because you go there, you reach one end, one extreme, and then you start your journey on the other side. So that means the velocity is 0. So kinetic energy will also be 0 at that point. So what we write is, at point B, your potential energy will be mgh. And also what I've tried to show is, if this is a reference line for mean position, this is a reference line for the extreme position. And you can see that the bob of the pendulum has gained height. That means it will gain potential energy. Since the velocity is zero, the kinetic energy will be zero. Now you, instead of writing mgh, you can write maximum as well. Also, at this particular point A, your potential energy will be zero because the body is at the bottom of the reference line, and at that time your kinetic energy will be maximum, will be same at C. So U is mgh, or it is maximum, and kinetic energy is zero. Okay, you shouldn't be writing minimum. Okay, you should not write this. It is maximum for this, but it is zero for this, not minimum. The mass of the ball as 0.20 kg, and the velocity is 20 meter per second, and you have to calculate the maximum potential energy. So now this is something I will write one time, and then you will have to write it in every question wherever we use this logic. Let me explain it to you one more time. That a ball has been thrown up. So at this instant, it has kinetic energy maximum. Okay, and if you want to calculate that, you have values like mv squared to do it. Now, as the ball goes to the highest possible height, now what is the meaning of highest height? That means the velocity becomes zero. The ball can't go any further up. So that instant, kinetic energy has become zero. So where has that energy gone? That energy has turned into potential energy, that is mgh. So if this is 500 joule, this will also be 500 joules. So what we will write over here is potential energy at the top is equal to kinetic energy on the ground. Now, why is this possible? Because as per the law of conservation of energy, that energy is neither created nor destroyed. It is transferred from one place, one form to another. Okay, if you read the question has given you mass, the question has given you velocity, but what is asked is the maximum potential energy. Do you follow that? If you want to find the potential energy at the maximum height, so that will be the kinetic energy on the ground, and that was half mv squared. So that is half into 0.2 into 20 into 20. So this will be 0.1, 0.1 into 400. So the maximum kinetic energy is equal to 40 joules. Here you will have kinetic energy maximum. That means potential energy will be zero. Here you have potential energy maximum. And everywhere, total energy will be same. That means, say the kinetic energy maximum is 40 joule. So potential energy maximum will be also 40 joules. But in between, say for example, if the potential energy is 20, kinetic energy will be 20, but the sum total will always be 40. So that is what I said, that total energy is same at all points. So again, we write down that statement. I am not writing it here, where the potential energy maximum or potential energy at the top is equal to kinetic energy on the ground because of conservation of energy. So potential energy maximum is half mv squared. That is half into 0.5 into 15 into 15. That is 225 upon 4. That is 56.25 joule. This is potential energy maximum. Kinetic energy maximum is also half mv squared. That is 56.25 joules. Total energy at all points is conserved. Total energy at halfway point. So 56.25 joules. In question 3 now, this should be easy for you all. When it was on top, potential energy is mgh. So this is 100 joules. And the second point, we need to write down the statement, and therefore kinetic energy just before touching the ground will be also 100 joules. And the third point, you know that okay, so when the ball is lying on the ground, stationary at rest, so potential energy is also zero, kinetic energy is also zero. So the 100 joule where it has gone, when the ball hits the ground, you hear the sound, so that is sound energy, and also the heat with the collision of the ball in the ground, there will be some energy dissipated in the form of heat. So when the ball hits the bat, the impact will leave heat over here. And you also must have seen that, sometimes the ball hitting a body, it leaves a mark also.
Yes, sir.
So there is a heat given out. And of course, the ball hitting the bat makes a sound. So some part of energy is also converted into sound. The height at point A, 75 meters. Point A, 75 meters. Height at point B is 15 meters. The first point, it says calculate the change in the potential energy. So potential energy at A is mgh, that is 60 into 10 into 75, 45,000 joules. And potential energy at B will be mgh will be 60 into 10 into 15. So therefore, change in potential energy is final minus initial. So that will be negative 36,000 joules. So 3.6 into 10 to the power 4 joule decreases. So potential energy has decreased. That means the ball will now possess kinetic energy. Now it says that 75% of energy in in A becomes kinetic energy at B. So 75% and 36,000 will be half into m into v squared. So this is 30, and there are two zeros gone. So 75 into 360 upon 30. So this cancels, and this will be 25. So I get a v square as 25 into 36. So when I take a root of it, that will be 5 into 6. So the velocity will be 30 meter per second. So that is my second answer. Like imagine there is a machine, and that machine is 40% efficient. That means it will generate 100 watt, but it will be able to provide you only 40 watt for usage. Okay, so suppose for example, if you are using it to run your car, then this machine is only going to provide you 40 watt, but it is going to spend fuel that will generate 100 watt. So that is the efficiency of 40% means. Now here what is happening? So this is a water reservoir, and that water reservoir, so water is dropping from a height of 50 meters. Now let us say that the water reservoir, water falls from a height of 50 meters. So if we assume that m kgs of water falls per second, then the amount of energy that it must be giving will be of power will be work upon time. That will be mgh upon 1, like 1 second per second. Now what is the machine doing of that? The machine is converting at a rate of 40%, and it is giving out 10 lakh of watt. Okay, 1 megawatt is 10 to the power 6 watt of mgh is equal to 10 to the power 6. Mgh is equal to 10 to the power 6. I will also write it in a different way, but if you understand this, so this is 40 upon 100. M we don't know, G is 10, and H is 50. And this is 3, 4, 5, 6. So how many zeros can I cancel? 1 here. And therefore, I have m into 4 into 50 is equal to these 6 zeros over here. So 1, 2, 3, 4, 5, 6, and down. So this cancels, and 5 fours are 20, and 20 will cancel 100 with a 5. So the answer is 5,000 kgs. Now I'm going to do it in a different way. We know the formula we have studied in the previous exercise also, that efficiency is power output upon power input. Now over here we know that efficiency is 40% and the power output is 10 to the power 6. So what is the power input? So 10 to the power 6 into 10 upon 4. And I just said that the power input is because of the falling of water. That is m into g into h upon 1, because this is per second. And this is 10 to the power 6 into 10 upon 4. So m will be 10 to the power 6 into 10. And this 10 into 50 goes down. So here it gets cancelled. And again, the calculations are same as we got over here. M will be 5,000 kgs. Okay, the question says that at this particular point, the pendulum has a velocity of 5 meter per second. That is the reason why I will call it as the maximum velocity. And when it reaches the highest point, okay, they are asking how high did the pendulum reach. But there is also a point that in the meantime, 60% of the energy that it possesses at A is lost. So therefore, energy at B is 40% of the energy which was at point A. So this is at the highest point where the velocity is 0, and this is H point where the velocity is 0, and this is H. That is 40% of kinetic energy, that is half m v squared, that is 5 and 5. M get cancelled, 10 into h, here 1 0 also get cancelled. So 4 into 5 into 5, and this is 10 into 2. 2 ones are, 2 twos are, 2 fives are 10. So you are left with only 1 5. This 10 goes down. So the height is 0.5 meters.